Hello, good morning, my dear students. This is again your Virat Kumar, lecturer in Electrical and Electronics Engineering from the Institute of Government Polytechnic, Vaddepalli, and I am here to discuss the subject of AC machines from the fourth semester, taking the code of 18EE403C from the topic of single phase transformers. And here we are looking into the subtopic of comparison between power transformer and distribution transformer, and also a small test of Sumpner's test. The class will be of around 50 minutes duration. There will be some PPTs, diagrams and animations also. So in the last class or the previous class we have learnt about all-day efficiency of a transformer. I hope you all have got the point regarding all-day efficiency, and I have given some multiple problems also in it, and I have explained and also given some example problems. So in order to practice, so I hope you all have done with that. So what is the formula for all-day efficiency? It is just the output energy in 24 hours in kWh by input energy in 24 hours in kWh. If we require a percentage efficiency, it should be multiplied with 100. So this was the formula which we have seen in the previous class, and I have given you multiple number of example problems, and I have explained you. I have given some 3 to 4 exercise problems also to you, so as to get practiced by yourself. And now we'll directly step into our today's. See, upon the completion of this topic, you will be able to know about the compare between power transformer and distribution transformer. Just compare power transformer and distribution transformer. And also we'll see how to know the efficiency of a transformer, by conducting Sumpner's test. No, just please make note of these 2 points. At the end, we'll be knowing about these 2 things. Now, we'll see the comparison between power transformer and distribution transformer. In general definition, the power transformers are used in the substations where it has a large capacity, and the distribution transformer used in the colonies to supply or distribute the power to the domestic, industrial, commercial, etc. So whereas the power transformer is used in the substations either for step up or step down, but whereas the distribution transformer is used to distribute the supply to the consumer, is always a step down. It's a general comparison. Now we'll just see the overall comparison between these two transformers. So firstly, we have particular power transformer and a distribution transformer. Is that clear? The first, nature of voltage. Nature of voltage. In a power transformer, either step up or step down the voltage. As I've said you in the previous, it is used for both step up and step down. And whereas the distribution transformer is always step down the voltage. Always step down the voltage. This is the first point, nature of voltage. It is either step up or step down the voltage, and whereas the distribution transformer is always step down the voltage. Make a note of this. Now, coming to the second point, efficiency. The power transformer has more efficiency, and whereas the distribution transformer has less efficiency. The reason is, always a distribution transformer is only connected directly to the load, not the power transformer. So here, since the load is falling on the distribution transformer, it consumes lots of current, by that it causes huge copper losses. So the losses are high, obviously the efficiency gets reduced. But whereas in a power transformer the losses are less, so the efficiency is more. Make a note of this. Now coming to the third point, application. These power transformers are used in generating stations and major receiving substations. As I've said you, these are used in generating stations and major receiving substations. But whereas the distribution transformer is used for distribution substations only. Let's make a note of this. So whereas a power transformer is large capacity used in generating stations for step up and for major receiving substations for step down, and whereas a distribution transformer is used only purely for distribution of substation, and it is always a step down. Make a note of that. Okay. In a continuation, the fourth one, operation conditions. Nothing but the nature of load. Operating conditions. The power transformer always works on near full load. It always works on near full load. Disconnected during lightly loaded or no load period. It is disconnected during light load or no load periods. And whereas the distribution transformer nearly works on 3/4 of full load. 3/4 of full load. What is saying? It is the operating conditions. Operating conditions. So whereas a power transformer always works on a full load, and if it is not a full load, like lightly loaded or no load condition, these power transformers are disconnected. And whereas a distribution transformer works nearly on 3 by 4th of full load. You see, this is a power transformer PT, and this is a distribution transformer DT, distribution transformer. Okay, let's make a note of this. Coming to the fifth point, contact with the consumers. Contact with the consumer. See, as I've said you, the power transformers are no direct contact to the consumers, whereas the secondary of the distribution transformer is always directly connected with consumer terminals. Directly connected with consumer terminals. The no consumer will take the power from the PT. Either it may be industrial, agricultural, commercial, domestic, anything else. The supply has to be consumed or connected directly to the distribution transformer only, whoever the consumer may be. Just make a note of this. And coming to the sixth point, size or rating of transformer. Size or rating of transformer. The power transformers are large in size, of about greater than 1 MVA, and the distribution transformers are smaller in size, of about less than 1 MVA, mega volt ampere. MVA indicates that mega volt ampere. Mega indicates 10 power 6. Make a note of this. We'll move on to the next. Okay, moving on to the next PPT. In the continuation, the seventh point, choice or selection. And again we have, this is the power transformer and this is the distribution transformer. The seventh point is choice or selection. That means what kind of a transformer has to be chosen or selected. So the power transformer is based on full load efficiency. It is based on the full load efficiency. It should be considered that the load is full load and what kind of efficiency is happening on it. So by that factor, this power transfer has to be chosen. And where is a distribution transformer based on energy efficiency? Based on energy efficiency. That means all day efficiency. It should be considered all day efficiency and has to be chosen or selected. Just make a note of this. And coming to the 8th point, winding energization. Winding energization. In the power transformer, both primary winding and secondary winding are always energized. Both primary winding and secondary winding are always energized. But whereas in a distribution transformer, the primary is always energized, but not so the secondary winding, because sometimes the load is always connected to the secondary, so sometimes the load may be connected or disconnected. So in that connection, the primary is always energized but not so the secondary winding. Make a note of this point. The 9th point, cost. The cost of the PT transformer is high since it is the large capacity. The cost of the distribution transformer is low since it is less capacity. Make a note of this. Okay, we'll move on to the next PPT. So I hope you have got some idea on the comparison between power transformer and distribution transformer. I hope you all have note the points, and now we just move on to the next topic of Sumpner's test. As in the previous, we have seen about open circuit test, nothing but OC test, and short circuit test, which are used to find the parameters of no load parameters and full load parameters, nothing but short circuit parameters. And the main concept of OC test is to find iron losses, and the SC test is to find copper losses. So now we'll see what kind of a test is Sumpner's test. So this test provides data for the finding, the regulation, efficiency, heating under load conditions, and this test needs two similar frame formulas. 2 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 So the Sumpner's test is used to provide the data for finding of regulation, efficiency, heating under load conditions, and this test needs two similar frame formulas. Just make a note of all these things. We'll be seeing one by one. Now, here is the connection diagram for Sumpner's test. You can see here there are two transformers of same capacity, same rating, and same connection. So that you can see here the connection diagram. Firstly, we have a single phase supply of phase neutral. By that, a voltmeter is connected in parallel to it in order to measure the voltage. So you can see the connections, and ammeter is connected in series in order to measure the current, and there is a wattmeter connection with potential coil and current coil. It is also connected in parallel. That is indicated as W1, which is used to measure the power, and the V is V1 and this is V2, A1, not V2. So these are connected on the primary side, so these are called V1, W1 and A1. And now these two transformers are so connected in parallel. See, it has a phase and a phase, the neutral to neutral. So these two are connected in parallel. See, the phase is given to the both. You can see here this one, this line, the phase also to this, and the neutral, it is over here. So this connection is on the primary side. So the meter readings was given like V1, W1 and A1. V1, W1 and A1. Since there are two transformers, these two transformations, both I0 at no load and I1 as primary. So the two I0 currents are doubled, so here it is mentioned like 2 I0. And in the secondary side, you can see the I2 is delivering from the turns. So both these I2 will be measured by the ammeter A2 connected in series. The voltage is measured by V2, which is connected in parallel, and the power is measured by W2, which is connected in parallel. So these parameters are on secondary side, so these are indicated as V2, A2 and W2. These are in turn again connected to a auto transformer or a voltage regulator. Nothing but it can vary the voltage levels, just like a variac. This is a variac, variable regulator, or a simple auto transformer. So the secondary is connected to this variac or a voltage regulator, and the output can be supplied to the load. So this is the simple connection diagram of a Sumpner's test. And please make a note of this diagram. I'll just remove all the credentials. Just please make a clear diagram of this, clearly of both primary and secondary. This is the primary side, we are giving the supply, and this is the secondary side, we are taking to the load or to the supply. These two transformers are of core type of identical transformers. Okay, I hope you all have done with the diagram. Now we will move on to the theoretical concept of this. It's a Sumpner test on two identical transformers, as I've said you in the previous. Now you can see a Sumpner test on two identical transformers. Again there is a diagram, the same diagram. See here, the two identical, there should be two identical transformers are required to conduct Sumpner test, and is also called as back-to-back test, because we are taking the supply over here, and again from the secondary we are giving to the supply. We are taking the supply from here, and again we are giving the supply. So back-to-back test, it is also called as back-to-back test. So it requires two identical transformers are required to conduct Sumpner's test or back-to-back test. The second point is the primary of two identical transformers are connected. The primaries of two identical transformers are connected to supply of normal voltage and frequency. Two identical transformers are required to conduct Sumpner's test or back-to-back test, where the primaries of two identical transformers are connected to supply of normal voltage and frequency. Keeping the secondaries open, measure the readings of W1. Keeping the secondaries open and measure the readings of W1. First step is 5. First we need to keep the secondaries as open and measure the W1. W1 is over here. W1. Again the same diagram in order to analyze it. When W1 gives the core loss of both the transformers, W1, since the secondary is open, so the total current consumed in the primary only, so the entire W1 reading gives the core losses of both the transformers. If it is short circuit test, then the W2 gives us the copper losses. But here we have opened the secondaries of the two transformers, so the entire power consumed is in the primary, that is I0. So the W1 measures the power which is consumed for entire core loss of both the transformers. And now the secondaries of two transformers are connected in series. So you can see here the secondaries, see the primary and next this one to this are connected in series. You can see the connection over here. I'm showing with the green colored bar. You can see clearly over here. It is connected in series. The secondaries of two transformers are connected series with their polarities in phase opposition. With their polarities in phase opposition. With their polarities in phase opposition by conducting polarity test. You can check the polarities by conducting polarity test. Nothing but positive and negative. By that we can connect either in series or parallel. So we know that when a negative is connected to the negative, then it is series. Here you can see the polarity test, positive and negative. See here positive and negative. Here it is negative and positive. Actually this has to be given when if it is in parallel, one terminal is given to positive and the other to negative. But here both the terminals given to plus. So the secondaries of two transformers connect in series with their polarities in phase opposition by conducting polarity test. Now circulate the full load current. Circulate the full load current in the secondaries with the help of regulating transformer. So think this as a load, voltage regulator as a load. So circulate the full load current in the secondaries, which measures over here with the help of regulating transformer. With the help of this regulating transformer. Just please make a note of all these points so as to refer further. Now the current I2 in the secondaries causes current I2 in the primaries, by mutual induction. So as we know that the transformer works on the principle of mutual induction. So the current I2 in the secondary causes current in the primaries by mutual induction. The current I2 completes its path through the main bus bar. The current I2 completes its path through the main bus bars. These are the main bus bars. Shown in figure with dotted lines are the readings of W1 remains unaffected. Figure shown in figure with dotted lines, where you can see the dotted lines over here. Are you able to see this? Dotted lines. Are the readings of W1 remains unaffected? Measure W2, wattmeter reading 2, which is on the secondary, which will give full load copper loss, of both the transformers. As I've said you, when it is fully loaded or short circuited, the reading of W2 entire gives the copper losses of both the transformers. That is why he is saying that measure W2, which will give the full load copper loss of both the transformers. So knowing the losses, we can find the efficiency. So from the W1 we have got the iron losses, and from the W2 we have got the copper losses. So there are only two kinds of losses observed in the transformer. So knowing these losses, we can find the efficiency. Since we will be having the rating of the transformer, by that we can find the output, and we have the losses in our hands. The output plus losses gets the input, and finally efficiency is output by input. In order to find the temperature rise of a transformer, they are to be kept under rated load condition. They means the two transformers. These two transformers are to be kept under rated load condition. Under rated load conditions for several hours till maximum stable temperature is reached. Till the reached. Just make a note of that. Yeah. Please make a note of this. Primary current of transformer 1 is difference of I1 and I0, and primary current of transformer 2 is sum of I1 and I0. And because of the unequal currents in the primaries, one may have slightly less temperature than the other. Obviously, the less current has the less temperature, the high current has the high temperature, since the temperature depends on the current. Please make a note of this. So that is about Sumpner test. Now moving on to the problems. We'll be doing a problem and I'll give you some exercise problems. You can do it by your own. Now see, two similar 250 kVA single phase transformers gave the following results when test back to back method, nothing but Sumpner's test. So the main wattmeter W1 of 5 kilowatts and the secondary circuit wattmeter W2 of 75 kilowatts at full load current. So these are the two things given. I determine the efficiency of each transformer at 75% of full load at 0.8 power factor lead. So the W1 of 5 kilowatts measures the iron losses, and the W2 in the secondary measures the copper losses. C is telling us to determine the efficiency of each transformer at 75% of full load at 0.8 power factor lead. We have two similar transformers of 250 kVA each. The given data is full load kVA of the transformer is 250. Full load kVA of the transformer is 250 kVA. Main wattmeter W1 is 5 kW. Second wattmeter W2 is 75 kilowatts at full load. In order to find the efficiency of a transformer at 75% of full load at 0.8 power factor leading. So this is kVA. We need to convert this into kW of about 75%. Directly multiply with 0.75 into 250 into 0.8. Gets a 75% full load kW. See here. Total losses of both the transformers is equals to 5 plus 7.5 is equals to 12.5 kW. These are the total losses. As I've said you, this is W and WC. That's the total loss. And full load loss of each transformer should be by 2. That gets 6.25 kilowatts. And output of each transformer at 75% of full load with 0.8 power factor leading is, as I've said you, 0.75 into 250 into 0.8 gets the kW. This is 75% of full load. It is 150 kW at 0.8 power factor leading. Now we have output in our hand and the losses in our hand. We can find easily the input. So input of each transformer at 75% of full load is output plus losses. The output is 150 and the losses are 6.25 kW. This is a each transformer. This is also for each, since 250 kVA is for each transformer. Now we have input also in our hand of about 156.25 kW. Now we have input and output in our hands, and the efficiency of each transformer is equals to output by input into 100. It's 150 by 156.25 is equals to 0.96%. 0.96 into 100 gets into 100 gets the percentage efficiency of 96%. So the each transformer has the efficiency of 96%. Is that clear? Rated current is no load current, so it may be 2 to 6%. No load current will be very less. The main drawback of Sumpner test is that it requires two identical transformers, it requires two identical transformers. You can see here, it requires two identical transformers. Okay, there are some frequently asked questions. You can make them. That's it for today's class. Thank you.